All right, guys, today we're going to learn prime factorization. I say learn, but I should say review. This is definitely something you guys did in 5th grade. You even learned a little bit of it in 4th grade. So go ahead and put your name and your date at the top. Okay, right off the bat, prime factorization. Make sure you capitalize that P at the beginning of your sentence. Prime factorization is when you break down a number till it only is represented by its prime factors. You'll remember that a prime factor is a number that can go into a number that is prime. Most of our prime factors are going to be 2s, 3s, 7s, 11s, a lot of that you're going to see, and 5s, I'm sorry. 5 is also a prime factor you're going to see a lot. So, to find the prime factorization, the first thing you're going to make is a factor tree. And even if you're thinking in your head, what in the world is that? The second I make one, you're going to be like, oh yeah, I totally remember. So, your factor tree is going to be made up of 2 different parts. Basically, like a normal tree, it's going to be made up of what we call stems and leaves, is what I like to call them. You're going to break up your composite numbers to find the prime factors. You're going to circle any prime factors because that's the end of each branch. You can't make it any smaller because it's already prime. Nothing else is going to go into it. When you only have prime numbers left, and I have a typo there if you want to add an S to the end of numbers, you write them as a multiplication sentence. To check and make sure you have the right answer, if you do the multiplication of that multiplication sentence, it should equal your original number. All right, let's look at it. So, we're going to start out with number 18. That's our composite number. We're going to make a factor tree, so we're going to have 2 branches coming off of it. Right now, your brain's going, oh yeah, this is familiar. I need 2 numbers that make up the number 18, and they could be any 2 numbers. I'm going to pick 2 and 9. Now, I know from my divisibility chart and my hundreds chart that we colored in, that 2 is a prime number, so I'm going to circle it. And once I see a circle, I know I can't break this down any further. 9, however, can be broken down into smaller parts. I know that 3 times 3 equals 9. I also know that 3s are both prime numbers, so I'm going to circle them. My next step was to go back and write them as a multiplication sentence. So I would simply write all of these, 2, 3, 3, and put multiplication signs between them. If I wanted to check it, 2 times 3 is 6. 6 times 3 is 18. What do you know? That's what I started with. Now, before you freak out, let me tell you, it doesn't matter what you choose to multiply this number by, because your prime factorization is always going to end up the same. So let's try 18 again, but this time instead of doing 2 times 9, I'm going to write 3 times 6. Again, I know that 3 is a prime number, so I'm going to circle it. I know that 6 is not because it's an even number, which means I can multiply it by 2. I'm sorry, I could divide it by 2. I know that 2 times 3 equals 6. And I know 2 and 3 are both prime, so I'm going to circle those. I have no numbers left that I need to break down any further, so I'm going to write it. I'm going to have 3 times 2 times 3. Even though they are in a different order, I know that that's going to be the same thing because of the commutative property. 3 times 2 is 6. 6 times 3 is 18. Notice I have 1, 2. I have 1, 2. I have 2 3s. I have 2 3s. So go ahead and pause the video and try doing the number 32. All right, so 32. I'm going to start this out one way, and if you didn't start it out the same way, that's okay. Wait until the very end to see if you still came up with the same prime numbers. I know 4 times 8 gives me 32. All right, I'm going to focus on just one side. 4 I get by multiplying 2 times 2. Those are both prime, so I'm going to circle them. 8, I know I write 2 times 4. 2 is prime, so it gets a circle. 4 is composite, so I need to break it down further. Again, I'm going to get 2 times 2, which are both prime. So the prime factorization for 32 is 2 times 2 times 2 times 2 times 2. When I have a lot of the same numbers like this, I like to go back and count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I wanted to check it, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Again, I'm going to show you. If you started out a different way, let's say you weren't sure about 4 times 8, but you recognize 32 is even. So you know 2 times 16 is 32. 2 is prime, so I'm going to circle it. I'm going to break down 16 even further. I know that 4 times 4 makes 16. 4 is composite, so I'm going to break it down further to 2 times 2. And both of those are prime, so they both get circled. 4 times 4 is 2 times 2. Sorry, that got a little messy. And I'm going to circle both of those because they're prime. Again, I have 2 times 2 times 2 times 2 times 2, which would be 32. It's the exact same answer I came up with over here. So you see, you don't need to worry about what you're multiplying by. There's no right way to break it down as long as the number sentence is correct. So you only have 3 today to do. I was nice. You can thank me later for it by being kind tomorrow. Once you're done with those 3, make sure you're writing out the prime factorization. The prime factorization itself is this multiplication sentence. Just because you finish the tree does not mean you're done. You have to write this multiplication sentence out. See you tomorrow, guys.